All right, in this video, I'm going to cover section 2.6, intersections of events and multiplication and total probability rules. So 2.6. Um, we're gonna, so the objectives, the first objective is to learn the multiplication rule, and then second objective is the probability, is to learn the total probability rules. Okay, so first one, multiplication rule. So we haven't seen multiplication rule, but which is a PA intersection B. Okay, so we're gonna express probability. We haven't seen the similar to multiplication rule when we study conditional probability. In the conditional probability, PA bar B, which means that probability A that event B is already occurred. That was a P of A intersection B over probability of B, right? So when I cover this one, when I introduce conditional probability, this one, I mentioned that we could express that PA intersection B in terms of conditional probability. That's a multiplication rule here we're going to study in section 2.1. So A intersection B, this can be expressed as, see here, if we just multiply by P of B on both sides, we're going to get this PA bar B times P of B. So like this. Okay. So, or we could express this one as like this P B bar A, which means the probability B, given that event A is already occurred. Like this. Okay, so that's a probability multiplication rule. So we see example 2.19. So give me a second. All right, so see example 2.19. So probability that the first stage of a numerical controlled machining operation for high RPM pistons meet the specification is 0.9. So, and then, yeah, the problems, the first sentence, they give us the information about probability. The first stage of numerically controlled machine operation for high RPM piston is a 0.9. Okay, so let me say, let's say the event, let's say the that event, I mean, first stage of numerically controlled machine operation, high RPM piston, say A. Okay, then P of A gonna be 0.9. And the failures are due to meter variation and fixture alignment, including blind condition, vibration, and ambient environment conditions. So given that first stage meet a specification, so that's the event A, right? Given the event A already occurred, the second stage of machining meets the matching machining meets the specification is 0.95. So let's say event B denote the what the second stage of machining specification B, okay? Then P of B, given that event A, which is first stage meets specification, is already occurred, is 0.95. So 0.95 represents conditional probability, okay? And the zero point 0.9 is a probability A. There was a probability that both stage meets specification. So the problem asking us about the what probability of both specification and probability that event A and B, both events are occurred. Okay, then we use a multiplication rule. So which is PA intersection B is, because in look at this, when you look at the problem give us the conditional probability, which is a PB bar A, and then so we can figure out P of A intersection B in terms of PB bar A conditional probability using that multiplication rule. Okay, so times the P of A, which is 0.95 times 0.9. Okay, so next one is this. Right here. So next objective is total probability rule. Okay. So again. Okay. So think about this one. Let's say this is the sample space. Okay, S. Okay. So let's say this is event A right here. Okay, all right, and then let's say B is like this. Okay, let's say B. Then that one, this part gonna be what? A intersection B. Okay. And this part, you see that? Let me give me a second. So that is A intersection B right here. Okay. Okay. And then the other part, by the way, actually this is A complement, right? So A complement, right? So sample space can be expressed as A union A complement, right? This makes sense, right? And then now the what about that part? That reason, the subset, I mean the subset going to be what? A complement intersection B, right? So A complement intersection B. This makes sense. So actually B can be expressed as what? A union, A intersection B, the union A complement intersection B. Does it make sense? Okay. So now then what? I want to find out probability of B. Okay. So probability of B is going to be, since we figured out B is equal to A intersection B union A complement intersection B. So this is equal to probability of what? Probability of A intersection B union A complement intersection B. Okay. So now then, remember that in addition rule, the probability of E1 union E2 is equal to probability of E1, right? And then plus probability of E2 minus probability of E1 intersection E2, right? So if two events E1 E2 are mutually exclusive, it means that there is no overlap common outcomes. Then that probability of E1 intersection E2 going to be 0, right? So now we're gonna check that whether or not A intersection B and A complement intersection B has common outcomes. No, because you see that A intersection B, A complement intersection B is completely what? Mutually exclusive, right? So then this is equal to probability of A intersection B and then plus probability that A complement intersection B. Okay. And then minus no, we don't have to do that because two events A intersection B and A complement intersection B are mutually exclusive. As you can see that there is no common part. So now common outcomes. So now then, now we're gonna apply the multiplication rule. So P of A intersection B can be expressed as like this. In terms of the conditional probability right there. So this is equal to P C B bar A and then P of A. Okay. Oh, wait a second. Why do we have to choose? Why do we have to apply this, not that one? If you just apply this one into here, that doesn't make sense because we want to express P of B in terms of other probability, right? But P of B equals P of A bar B times P of B. That doesn't make sense, okay? So here we assume that we want to find out P of B, which means that we do not know P of B. Then we express P of B in terms of PB. That doesn't make sense. So now let's see. Now plus, and then this one is what? P, you can say B bar A prime, and then P of A prime. Let's see. Okay, we can express that. Okay, so we applied that multiplication rule here and here, we got this. So P of B could be expressed as totally in terms of conditional probability relating to A. Okay, that's a total probability rule. So now then, give me a second. So you see example 2.20. All right, 2.20, semiconductor contaminations. So consider the contamination discussion at the start of this section. Yeah, remember that? You see, we haven't seen the similar the table with to this in the previous sections. Okay, so the information is summarized here. So probability of failure is 0.1, 0.005, and then level of contamination high, not high, and then probability of level is 0.2 and 0.8. So let F denote the event that the product fails. Okay, so now let's see, fail. So now then, and let H denote the event that the chip is exposed to high level of contamination. Okay, so now then the requested probability is P of F, and the information provided can be represented as like this. How come? Let me the let's figure out why these where how come we're gonna get these probability from the table by drawing Venn diagrams. Give me a second. Right. So let me. I was drawing the Venn diagram representing the all the probabilities events in the table. So first one, you may wonder that okay, so in here to apply, yeah, definitely we're gonna apply the total probability rule. So then you may wonder that you may just have question that how can you know that uh we need to apply the probability rule? So when you look at the problems, give me a second. So here, yeah, so in this, look at this. So the question is to find a P of F. But you may say that, okay, P of F isn't that P of F is just 0.1 plus 0.005? No, because zero point 0.1, what does a probability of table failure? Is zero point 0.1, that is not the probability of failure. That 0.1 represent the probability of failure given that the level of contamination is high. So 0.1 is not the P of F, actually P of F bar H, conditional probability. And the 0.005 is also similar. P of F, give me a second, given that level of contamination is not high. So 0.005 means the conditional probability of failure, given that level of contamination is not high. Okay. So then it means that we need to express P of F in terms of the conditional probability. That's why we have to use total uh, probability rule. So now then, and here, so okay, total probability rule. We know the formula right here. So then, which I mean, here A, see total probability rule with two events A and B. Then which event out of A, I mean event F in this in this that problems, the A means F, I mean probably the failure, or B means the level of contamination. In this case, keep in mind this, when you apply the probability rule, you see that here, POB, we express in that rule, we did express POB in terms of conditional probability. So now in the example 2.20, we want to express P of F in terms of conditional probability. So now we have to apply event F into B. Okay. So now then, so now that's why I drew the Venn diagram like this. Okay. So instead of, I mean that B uh, is what becomes what F right here in the problem example 2.20. So now that F here, then this is going to be H intersection F, and then this is H prime intersection F, right? Okay. So then P of F is equal to, see, probability of what? This one, probability of H intersection F plus probability of H prime intersection F. That makes sense, right? So two, see, two subset H intersection F and then H prime intersection F is mutually exclusive. So we could express P of F as like this. And now this is equal to what? P of H of intersection F, applying the multiplication rule. We got this. P of, okay, so F, I mean, so, okay, so let me say this is H bar F. You can say that. And then P of F. You may just, apply the multiplication rule so that we got this. But now you see that we don't know P of F, and we express P of S like this, plus something. That doesn't make sense, right? Since we don't know P of F, so this is wrong, right? So now this is equal to P of H, F bar H, and then P of H, because we know P of H, because the problem says the probability level, I mean, high level contamination is 0.2, right? Look at the table in example 2.20. So we know, okay, and then probability of F bar H prime, and then probability of H prime, okay. So now this is equal to probability P of F bar H, problem says what? This is 0.1, P of H, probability of high contamination, 0.2 times 0.2, and the plus, and then P of F bar H prime, which means the probability of failure, given that the level of contamination not high, which is 0.005, okay, times probability of what? Not high level of contamination is a 0.8. Okay, so this is, and then you just, that should be 0.024. Okay. Now, so we're gonna extend the probability rule to a multiple event. Okay, so total probability rule. Okay, so think about this. So think about the multiple events in simple speed right here. This is E1, okay, E2, E3, okay, through E, no, maybe say N, okay, all right, and then event B can be is right here across E1 through En, okay, then that's going to be that part. See that? This part, that's going to be E1 intersection B, right? E1 intersection B. The second one is what? E2 intersection B, right? So now then, the probability of B, B can be expressed as what? E1 intersection B, right? Plus a union, union E2 intersection B, union through the what? Union En intersection B, is it? So now then what? Now let's find the probability. Then P of B, okay, this can be expressed as what? This is equal to probability of E1 intersection B plus probability of E2 intersection B, right? Plus through the plus probability of En intersection B. Now we apply the multiplication rule for each terms. Then what? We got this. P of B is equal to probability of what? B bar E1 times P of E1 plus PB bar E2 times probability E2. Okay. Just give me a second. Is what we got the autofocus. So yeah, we could express P of B as like this, right? Plus and then through the P of B bar En times P of Pn, right? P of En. So that is equal to, right? Yeah. So yeah, let me express this one shortly using sigma notation. Sigma, right? So k is equal to 1 through the n, and then P of B bar Ek, and then probability of Ek. Okay. So this is a general, yeah, the general form of total probability rule. Okay. So that's for the 2.6. The next time I'll cover 2.7.